Okay, so what we have here is a expression that we want to try to simplify, and by simplify we just mean let's try to make it, maybe one term if we can get there. So since this expression deals with double angle identities, basically makes sense to try to replace the double angles with single angles. So just remember, sine of 2x is 2 sine x cosine x. And we actually remember have three different versions of cosine of 2x. So I'm just going to jot those down really quickly here. And we had 1 minus 2 sine squared x. We also have 2 cosine squared x minus 1. And those are all cosine 2x. So the beauty of this expression is I only have one possible replacement for sine of 2x that's actually going to be useful. And that's this one right here. So I'm going to go ahead and I'm going to write 1 plus 2 sine x cosine x, and I'm going to leave a blank. And in the denominator, I'm going to write out 1 plus 2 sine x cosine x, and I'm going to leave another blank. Because in order to make use of simplifying, when I think of a fraction, I think of common factors. And what I need to get rid of probably is that 1 that's sitting over here. So I want to replace cosine squared x. I didn't do the right thing there. I want to replace cosine 2x with something that's going to maybe get rid of those ones. And we notice that we can possibly do that. So I'm going to put in parentheses here my replacements for cosine of 2x. Looking at the numerator, I already have a plus 1, so I'm going to replace cosine of 2x with something that has a minus 1, and that's going to be this one. So I'm going to put here 2 cosine squared x minus 1, and in the denominator, I mistakenly wrote a plus there, so I'm going to change this to a minus. And the choice of cosine 2x I went there is, well, if I'm subtracting, I want to make sure that I'm subtracting a positive 1. So I'm actually going to use this one in the denominator. So we're using two different versions of cosine 2x in one problem, but we'll see why exactly we're doing that. So we do the algebra. In the numerator, the 1s are going to cancel out, and we're going to get 2 sine x cosine x plus 2 cosine squared x. And in the denominator, well, this is going to be minus 1 plus 2 sine squared x. So it's going to be 2 sine x cosine x plus 2 sine squared x. And from here, it's a little bit more clear where to go. We notice that the numerator and denominator each have common factors. In fact, I'm going to take out a 2 cosine x in the numerator, and that's going to leave me with sine x plus cosine x. And in the denominator, I'm going to take out a 2 sine x as a common factor, and that's going to leave me with sine x, or cosine x, plus sine x. Now remember, adding in either order, they're the same, right? So these two quantities are the same, which means they're going to be removed as common factors. So that's good news. And the 2's can also cancel out. So it appears that this entire expression is the same as cotangent of x, which I think you would agree is much simpler. So there we have it.